Okay, the question states that we have to predict the nature of both of these complexes. So, and all of your options states whether it's going to act as an oxidizing agent or whether it's going to act as a reducing agent. So, for this you can either find according to the effective atomic number rule or you can find according to the 18 electron rule. So, according to the effective atomic number rule, if the atomic number does not come equal to your atomic number of a noble gas, if the effective atomic number comes like 1 less than the atomic number of a noble gas, then it is going to get reduced and it will act as an oxidizing agent. And if the effective atomic number comes 1 or 2 greater, twice or 1 or 2 electrons greater than the atomic number of a noble gas, that means it will have to lose those 2 electrons so that it can achieve the noble gas configuration. So that means it is going to get oxidized and will act as a reducing agent. So I personally prefer the 18 electron rule over the effective atomic number rule because it is easier to know which group your central atom belongs to, even if it's something like tungsten or iridium. It's not always easy to remember the atomic number, but it is always easy to remember the group to which they belong to. So I'll be doing the atomic number the 18 electron rule here. You can do the effective atomic number rule. It's totally upon you. Okay, so predict the nature. First, we'll predict the nature of this. Mn belongs to group 7 and the oxidation state of manganese here is X plus 6 into CO is equal to 0. That is, and CO is a neutral ligand, so it will be X is equal to 0. So oxidation state of manganese is 0. So 7 minus 0 plus 6 into 2. So that is 7 plus 12, which is equal to 19 electrons. So 19 electrons is 1 electron more than the 18 electron. So it is going to lose an electron, and if it is going to lose an electron, it is going to get oxidized and will act as reducing agent. So manganese is acting as reducing agent. Here Ra means the short form of reducing agent. Now let's talk about this. Vanadium. Vanadium belongs to group 5. Its oxidation state here is also 0. You can calculate it. Its oxidation state is 0 plus 6 into 2. So that is equal to 17 electrons. So it is 1 less than the 18 electron rule. So if it is 1 less, vanadium is 1 less than the 18 electron rule. So if it's 1 less, it is going to have to accept 1 electron, and if it accepts 1 electron, vanadium, this complex is going to get reduced, and if this complex is going to get reduced, this means it is going to act as an oxidizing agent. Here OA is the short form of oxidizing agent. So it's not actually a short form. Okay, this is just why I am writing it as a short form. Do not write OA and RA in your exams. Okay, so now let's see which option states that correctly. So first option states that MnCO6 acts as an oxidizing agent. So no, that's not true. Second option states that this acts as a reducing agent while VCO6 whole acts as a oxidizing agent. That is true. C, both are oxidizing agent, that is also wrong, and D, both act as reducing agent, that is also wrong. Okay, so this question is not directly related to the effective atomic number or your 18 electron rule, but this is a more general type of question, but it's a really good question. So let's see what this question asks. This question tells you, first of all, that ammonia forms the complex ion CuNH3 2 positive with copper ions in alkaline solution, but it does not form that in acidic solutions. What is the reason for it? Okay. So ammonia, it says ammonia forms a complex ion with copper ions. So this is ammonia. Ammonia is basically acting as a ligand everywhere because it has a lone pair of electrons which it can donate to the metal atom. That is why it is behaving as a ligand. If it is put in an acidic solution, the acidic solution is going to have protons, and the proton does not have anything. Right, proton is called a proton because it just has a proton. It does not have anything. It is like the poorest of the species. So ammonia, this lone pair of electron, it's going to donate to this proton. It's going to form an ammonium complex. When it forms the ammonium complex, the lone pair of electrons has already been donated to the proton. So if the lone pair has already been donated to the proton, now what is left to donate to the copper atom or the copper ion? Nothing. So if nothing is left to donate to the copper ion, why is copper ion going to form a complex with ammonia? So that is the reason why. That is, if in a acidic solution, ammonia tends to form ammonium ions, and ammonium ions cannot form a complex with copper ions because there is no lone pair left for donation. So that is your option A. Option A states that in acidic solutions, protons coordinate with ammonia molecules forming NH4 positive ions, and NH3 molecules are not available. That is the correct answer.